Thank you.
Yeah. Oh, there was one to pick. Yeah, are there any climate change deniers among you? No? Okay. Because then this presentation would have been a little bit hard for you, because this is what this is about climate change, the carbon dioxide and the carbon footprint of facility services. And doesn't matter if you believe in climate change or not, it will affect us all in the future, because new rules and regulations will make us deal with it, and in the field of facility management and facility service as well. So, but why is that so? Probably you all have heard of the so-called Paris Agreement, but probably you don't know really what the Paris Agreement is all about. So I'm just going to give you some quick facts about the Paris Agreement. Well, its central aim is to respond to the climate change, and by keeping the temperature rise well below 2 degrees, prepare to pre-industrial levels, and of course by reducing greenhouse gas emissions. Well, the 2 degrees Celsius, they are very optimistic. We are talking now about 1.5 degrees. And, well, if we won't get these 1.5 or 2 degrees, well, it's going to be very bad for us on this planet. So we will have to deal with it, like I said, whether we want to or not. In Germany, for example, we have the German Climate Action Plan 2050, which basically is saying that Germany wants to reduce greenhouse gas emissions to 0 by 2050. The Paris Agreement says that we have to reduce our greenhouse gas emissions on this planet to 0 by the end of the century. Facility management and facility services will be a part of this reduction, of course. A preceding case study, for example, found out that we have potential of optimizing the carbon footprint of a whole facility only by optimizing its services for about 10%. So we could do a lot for each facility only by optimizing facility services. But to optimize facility services, we would need to know the drivers of the carbon footprint of the greenhouse gas emissions of each service. And I guess most of you wouldn't know what the drivers of the facility services are, or what the carbon footprint of the service of facility service are. Has any one of you ever calculated something like this? I guess not. You have, okay, some have. The problem is there's no easy method to do this yet. Well, the standard and life cycle assessment is the ISO 14014. This one, do you hear me? You still hear me? Well, I didn't hear myself anymore. Okay, sorry. It consists out of 4 successive steps. Well, it's the goal and scope definition. It's the life cycle inventory analysis. It's the life cycle impact assessment, and it's the interpretation of all these. Now, this doesn't look very complicated, probably, but especially life cycle impact assessment and the life cycle inventory analysis are very complicated steps. So if you look at the life cycle of a product, for example, you would have to find all the inputs and outputs of the product over its whole life cycle, starting from raw material extraction, manufacturing, transportation, use, and disposal. And for one single product, this might take up from weeks to months to find all the inputs and outputs. So if you wanted to start to improve your facility services, for example, you wouldn't want to spend weeks to months just to find out what are the drivers, what is the carbon footprint of your service, how can I improve it. So we wanted to create a method to do this within minutes. So CarMa is a method and a tool which is going to help you to find the drivers of your, the greenhouse gas emissions drivers of your facility service and to improve that. So how do we do that? Well, first, you would have to define the functional unit of your facility services. So basically, what does the service do? This is not, these pictures you see here, well, this is not really a facility service, but it demonstrates it very well. In each picture, you see the same result. You're getting a pair of hands dried. Yeah, that's. The inputs are different. Well, you have paper towel on the one side, you have heat or electricity or energy on the other side, so the carbon footprint would be different, but the result is the same. So if you want to improve your carbon footprint, well, you probably have to look at the inputs and the outputs and say, well, this is the carbon footprint of this service, this is the carbon footprint of the other service. They all have the same output, but I can improve my carbon footprint by just using the different service. So according to ISO 14040, you would have to do some, define some more figures like system boundaries. If you have this, you would have to start to get all the inputs and outputs. And like I said, well, this is a very complex process. So we, from the CarMa project, we want to simplify this a little bit more. So if you take, for example, the service of maintenance cleaning, for the service maintenance cleaning, we defined the functional unit keeping a square meter clean over a period of 1 year. And each service, we just break down to 4 module groups, like equipment, operating consumables, transportation, and overhead. I guess you know what the first 3 of them are. Overhead, these would be service-related management costs, like duty scheduling, customer service, invoicing, etc. So which are really related to the service. And they would all add up to some X, to a carbon footprint of this special service. Now the tool, we are creating a tool. I would have liked to present you some screenshots of the tool here. Unfortunately, we don't have them yet, so I tried to build it in this presentation. Now the tool would give you 2 figures. First is the estimated share, and the second one is the overall improvement potential. Now the estimated share is due to bad data availability and data quality. Unfortunately, it's hard to get really good data, which you would need to calculate the carbon footprint of our service. Now, best case, it would be 0. Now, the overall improvement potential would show us what the potential is to improve our service regarding the greenhouse gas emission of the service. And we have these 2 figures in each of these module groups as well. So let's say the equipment shows us a very high overall improvement potential. So we might want to start to improve our equipment rather than the transportation if this has a very low overall improvement potential. So on the software, we just could click into the equipment and we would come to a next page, which basically looks like the first one. The equipment page, for example, for maintenance cleaning, we have a dry vacuum cleaner, we have the mops, we have a cleaning trolley, and we have the working clothes. It could be different. Well, this is our example, and we said, well, we want it to keep it really easy and simple, so that the tool is very easy to use. They add up to the carbon footprint of the equipment. We have the estimated share again and the overall improvement potential. So let's say the dry vacuum cleaner has an overall improvement potential of let's say 5%, 10%, 15%, doesn't really matter. This is because we have a database running behind the tool. Probably we have a better dry vacuum cleaner in the database. This is why this would show us improvement potential. So we probably could just improve our service now by swapping the vacuum cleaner with the better one we have in the database, and the service would have a better carbon footprint in the end. Now you see the red and green borders around the equipment here. What does that mean? Well, in best case, we are getting the carbon footprint of each of our equipment directly from the manufacturer out of so-called EPDs, Environment Product Declarations. So unfortunately, many manufacturers don't give us their carbon footprint of each of their products yet. So in this case, we have to estimate it. And this is unfortunately a very difficult way to do. And in CarMa, we wanted to find an easy solution to estimate the carbon footprint of the products we're using if we don't get them from the manufacturer. So how do we do that? Well, if you just, for example, take the vacuum cleaner, And then we just looking at the key facts like the weight and its components that it's made of, like plastic, metals, and others. And then we are looking into special databases which are usually free available for each of these materials used. And then in the tool, we have a special formula. We are still working on this formula. We have some tests already running, and it looks quite promising. This formula is looking at the life cycle, like I showed you before, and it adds it up to the carbon footprint of, for example, this vacuum cleaner. And yeah, the formula will be adjusted probably in the future. We are still testing, like I said. The project is still ongoing. So if you have any further questions regarding this project or the ongoing, or if you want to follow us, have a look at our website, or have a look at the proceeding in the paper, or talk to me or to my colleagues afterwards. Thank you.
Thank you very much, Stefan.